everyone, thanks for joining the talk. Today I am Mohammed Nassar. I am from IBM Haifa Labs. Today I'm excited to show you or to talk about the interesting integration between DataPrepKit and the agentic workflows, which is a hot topic today. This work was done by Alexei, Revital, and me. So today we'll explore how we can integrate or how we can use the powerful agentic workflow or LLM agents to potentially automate the preparation of data or running the data PrepKit pipeline. So the agenda for today is we'll start with the introduction to LLM agents and LLM agent workflows to be in the same page. Then we go to the benefits of agents for our case. Then we will show how we integrate the DPK with agents. Then we will show two demos, and in the end we will wrap up with the summary and the challenges. Okay, so first, let's start with the introduction to LLM agents or AI agents. So the LLM agents are systems built on LLMs that expands the notion or the simple text generation that the LLM starts with. They are assistants or automated assistants that can reason through problems, that can plan actions and execute these plans using tools and the memory and so on. So in other words, we can give us a title for the agents that the agents enable transformation from plain text or description to a specific technical operation and steps and execute these actions. So this diagram, let's start with this diagram. It's giving a high-level overview of the architecture of the agents. So starting with the user can ask for some goal, some task, some prompt, give it to the agent. The agent is the goal of the agent is to understand this prompt or this task and to think and plan how to achieve this. So in order to do this, it has some other assistance. So we have here prompt template. It's the part of giving the context to the agent, giving him constraints, some instruction, telling them how to think or how to work, and so on. Second part is LLM, that the agent, in order to understand the task and to break down to steps, to sub-steps, and to make plans, he uses the LLM. And the main part or the differentiator of all the concept of the agent is the way that the agent not just generate text, but it's also interact with the outside environment or the outside world and perform some actions. So this part is doing this part by the section of the tools. So he can, for example, run actions or tools, for example, like a web search, make some complex calculation, or in our case, also running a DPK transform or DataPrepKit transform. And the last component here is the memory that the agent can use it to store the history of the prompts or the history of the conversation, the tools results, or some other information or data. So this is about AI agents. You can stop me when you want to ask something. It's okay. So now let's go to the notion of agentic workflow. So it's an example of workflow that can help us in the coming demos. So let's go over this agentic workflow. It's the process how the agent performs the task. So starting with the query, the user query here. Here it's written in natural language, in plain text. Okay, so go to the AI agent. The AI agent start with thinking and planning. So this step is crucial for breaking down the user query, the task of the user, to subtasks, to small actionable tasks that can be done. This is done by the LLM, using the LLM. The next phase is the act phase, which is we have now the plan, each with the steps. Each step is performing a tool. So we execute this. The agent executes this tools according to the plan from the previous step. After that, we go to the next phase, which is the observation phase, which is very crucial for the complex tasks and the tasks that has errors or something, because here in the observe phase, the agent check the results. So what was the output? Did the tool work correctly? Was there some errors, or it checks all the needed checks, and uses reflection to analyze the outcome against the what desired output or what the goal that we want or the user wants. So after that, if the observation phase decide that it's need a revision, so we go iterate back to the think and plan step. And this is very crucial, because when we have problems, we don't want to fail and finish. No, we want to try to make some iterations, to make some improvements, maybe to replan or reconsider the plan that we had in the first try. So if needs a revision, we go back and go to the loop, starting the loop from the beginning. Otherwise, if the result is okay, we finish and go the response, and we return this to the users. Okay, so let's go to the next slide. So why is agentic workflow beneficial, especially for when we talk about data preprocessing tasks, which is a complex task, because for data preparation or processing, we generally need more than one step, more than one transform. It's not just one transform. So first of all, the agents can handle complex tasks efficiently, and can generate plans, run code, and test this code, and as we saw in the observation, and run benchmarks, and do all, can add so many tools to it. Second, robustness and self-correction. So the agent can analyze their own output, check the output with the reflection if it's as the goal that was expected, and make necessary improvements or reconsideration or replanning. Third, tool integration, which is the main thing in the agents, because the tool can give the agent the ability to interact with the outside world, or the outside environment, and also it help the agent to be extendable, because we can add more tools to the agent, and this will add more capabilities to the agent. And lastly, autonomy. All that we saw with the entire cycle of planning, acting, observation, revise, all of this is automatic. So the user just put the initial query, and the agent handle all the iterations there. Okay. So now let's go to the let's bring the DataPrepKit, the DPK pipelines together with the LLM agents, and show the integration between them. So we did two main contributions in this field. So the first one is simplifying the DPK pipeline creation. So instead of creating notebook or Python file that has all the code of importing the DPK transforms and what transform we need and to put the input parameters and so on, that maybe part of you saw in the previous talks, how we can create a data DPK pipeline. So instead of that, our goal or our mission is to use to help or to enable users to interact with DPK using a natural language interface. So that imagine describing the data transformation that you need in plain text. I want to filter the data X and Y and then so on. And by describing this task that you want, the system or the agent can build for you the pipeline that you want. Okay, this is the first one without coding. So this is the first one. The second contribution is making the DPK transformers as make them available as tools for other agents. So for that, we wrap this transform, the DPK transforms, as LangChain and Llama Index tools. LangChain and Llama Index is too powerful agent management, so anyone can use it in different agents. So any user can provide his agent with these tools, so he can use the DPK transformers. So now let's start with the first demo. The first demo is about natural language to DPK pipeline code generator. In this demo, we show an LLM agent that takes a task in natural language and generate a Python file that can be used or run by any user. So it's deterministic. No need to regenerate all the agent from the beginning. So the output of it is a Python file that can be used by different users. And this the first demo. And before we go to the notebook, let's look at the graph in the right side here. This graph or this flow describe the agent, our agent in the notebook that we want to show. So in the beginning, we start with a user that asks for some pipeline, some transformation on his data. The first node is planner. The planner here takes all the context and suggests a plan. The plan here is steps. Let's make eddoop in the beginning, and then let's make other transformation, and then the third transformation, and so on. After that, we go to the judge. The judge got this plan, and he revised it. He gave his view on it. If it's okay, if it's not okay, what to change, what is the problem on it, or if it's okay. So if it's need revision, so we go back to the planner and make this loop, this iteration. Otherwise, if it's okay, we add a step of user review. That user review is we want to interact with the user. We show him the plan that the planner suggested, and he can give his review to make a replanning or revision or to continue. So if you want to replan, we go back to planner and do a replanning. Otherwise, we go to the code generator. In the code generator, we got the plan, which is the steps of DPK transformers, and converting or generating from an LM generator that generated a Python file that can be run by any user or can be run more than once. That demonstrate the DPK pipeline that we want. After that, we have a code validator. We run the output, the generated code. We run it in isolated environment because we don't want to harm the user environment because it's auto-generated code. So we run it using Docker in an isolated environment, and we finish with the output. So let's go to the let me see here. Okay, so in order to see the DataPrepKit, to the notebook that we saw now, here is the open source, the DataPrepKit open source. We have examples here. In examples, we have Agentic, and we have planning DPK agent, this notebook that we want to show now. Okay, you can find it in the open source. So let's go over it. Here's the notebook. So in this notebook, we show the agent that the DPK agent that can take a natural language task and build a pipeline, DPK pipeline for it. So in this example, our example task is we want to process the provided PDF dataset to identify and extract only documents that don't contain inappropriate language, and we want to remove that application. So we have PDF files. We want to remove bad files and remove the applications. So in order to do that, here we have, before kicking off the agent, let's start with the context that we give to the agent. So first thing, we give it to the agent the tools. It's the main part, okay? So here, the tools that we give to the agent. For each DPK transform, we provide a JSON file or JSON dictionary that describes this transform. So for example, if we look at the doc quality, for example, we write here the name of the doc quality, the name of the transform, the description of the transform, what inputs that it got, and how we can import it in the Python file. Okay, so we do this for each tool, for each DPK transform. We also have here example task. In general, in LLM and prompting, it's good to give the agent or the LLM an example. Okay, so here we give him a small example for if we want to filter Parquet file to include only English documents. So we need first step language identification, and second step is a filter. That's an example of a plan, okay, to help the planner to give us more concise results. Also, we have constraints. We want to give constraints of the pipeline or for the flow. So, for example, exact dedupe must run as the first step or after PDF to Parquet. Tokenization must be in the last step, and so on. We can define any constraint that we want. All the context of this we give to the LLM in order to generate a good plan for us. Also, just a note, we currently support the 3 different ways to run the LLMs. One is Watson X, which need IBM, I think. Replicate, anyone can create an account here, and you can run it locally with Olama. For each option, you need to put the key or something according to what option you use. Here in our demo, I'm using a replicate with the Meta Llama 3 model. Okay. After that, let's run this cell. Okay. Now this cell is we define our graph. Okay. defining the graph by, as we saw in the slide, we have a planner node, judge node, user review, code generation, code validator. We use this using a LangGraph, okay? And we put all the edges between them with conditional edges, how we can run this, as we saw in the same as the slide, as we can see here. Okay, so this is the what we call the slide, and here in this cell, the last cell, is the kickoff of the agent. Okay, we start the agent with initialize it with all the task or the context that we showed before, and we can see here the result. So it started with the generate with the planner. Sorry. Okay, the planner suggests this plan. Each line, it's a JSON of a transform, and to make it easier to the user to check the plan, we printed it as a flow here. So we can see that it's PDF to parquet, doc quality, filter, exact dedupe, tokenization. So after that, oops, we go to the here. We are here. We go to the agent, to the judge. Sorry. Okay, the judge gave his view. Okay, so he said that, for example, exact dedupe must run as the first step or immediately after PDF to parquet, which is the constraint. So we can see that exact dedupe is not in the right place. Okay, so he suggests to replan. Okay, so need revisions, yes. So we go back to the planner. So now we can see that exact dedupe is run after PDF to parquet exactly, and the judge now said that he said that the constraint is satisfied, but he asked there's an here the plan doesn't ensure tokenization run as the last transform, so he need revision. After revision, it's back and forth. So we in the end we got to the user with this plan. Okay, with this plan. So I'm as a user, I want to remove, for example, the tokenization. So I can write here, no need for tokenization. Okay, so if we go to the graph, we are here in the user view. I am asked that I don't want the tokenization step in the last. So we go back to the planner, and now it suggests a plan, a different plan without tokenization. Okay, so before there was a tokenization as the last step. Now it's without tokenization. And I'm satisfied with this plan, so I can write OK or enter or something. So after entering this, we can go to the our VS Code, and we can see that this is the generated plan. The output of the generation step, generation node, is a file called LLM plan generated. That has the transform that we saw in the graph. It's PDF to parquet, then dedupe, then doc quality, then filter. Okay. And this file, what's good in this file is a deterministic output. So anyone can run it after that without all the need of planning on the LLM and so on. So this is a deterministic output that can be used by the user several times or by different users. So we remove all the LLM uncertainty here. We put something deterministic. And the last step will take time, so I will show you a previous run. So the last step now is running the DPK, the file, the DPK pipeline that we saw, running it in Docker, an isolated environment, in order not to harm or to make damage maybe to the environment of the user. So here you can see the output of the run. It's a lot of details, no need, but we can see that the output here is this file, in this directory output PDF to parquet dedupe doc filter, and we can show this result here. We can run a show parquet command with this output that we saw there. So the example that I run is I put two input files, one earth PDF and one marspad, so one good and one with bad words. And we can see then the output has only one file, just the earth PDF without the marspad. Okay, so it's if we go back to our task here, so it removes the inappropriate language files. That's it. Let's go back to the slide. Okay, so now we can go to the second demo with Revital.
Thank you, Muhammad. I just will share. Okay. Okay. Can you see my screen? You see my screen?
Now, yes.
Now. Okay, thank you. So as Muhammad mentioned, this is a trial we did, experimental trial to define DPK or implement DPK transforms as LangChain or Llama Index 2. And we wanted to test this implementation. And for that, we took existing notebook that already existed. Maybe Saji also showed it to you. It's from the DPK repo. And it does something like a RAG pipeline. It takes the PDF to parquet as the first step, and then chunk, split to chunks, and then document ID, exec dedupe, fuzzy dedupe, and lastly, vectorize and put it in a database. So we took this in the original notebook where we took it from. All these steps were done in separate cells, one after the other, where the input of a step of a transform was the output of the previous transform. So we wanted to see how we can do it more agentic and use this new implementation of the DPK transforms as the LangChain or Llama Index 2. So what we did, we tried to insert the task of creating this pipeline to define it in a natural language, like, for example, like this, to say execute PDF to parquet, doc chunk, etc. All these transforms when where the input of the transform is the output of the previous one. So let me just try and run this notebook together with you. I didn't say that this notebook is, as Muhammad showed you, is in the same directories notebook. So this we run it in this version, which is the default DPK transforms are defined as the LangChain tools. So let's run it. There is an option to run it with Ray. This is DPK can run with the Ray or Ray cluster or not, but we are running here in a Python version. So first we define the input task. As I said, this is we explicitly give the list of transforms that we want to be executed. But in addition, we will also provide values for the non-default input parameters for the transform. This is an initial version, but I guess that this can be in the future be expressed in natural language. But for now, for this version, we explicitly mention the non-default values, give them explicitly to the input in the input task. Okay, so this is the input task. I'll just go down. This is a minute. I think I'll Yeah, I'll just turn off my camera. I think it's slowing a little bit. Okay. Okay. Do you see my screen? Do you see my screen?
Yes, we see your screen.
Okay. So this is the task that is being given that we are passing to the LLM. Oh, just a minute. It's a little bit probably connectivity issue. Sorry about that. Okay, so it's execute this list of transforms where we have these non-default values also passed. Sorry about that. It's a little bit slow. Okay, so this is the task that we're going to provide to the LLM. Then we're going to have the LLM defined. So here, as Muhammad also showed, I'm also using replica. And then we're going to pass to the call also the list of transform as we defined it, the implementation as LangGraph tools. So this is where we are passing it as a string, the description as we're implemented it as LangGraph tools. Okay, and this is the prompt. So the prompt we are passing is very similar to React prompt. We just mentioned what we expect to get from the result. We expect that we have this action and action input, where the list of action and action input, where each action is the transform that we want to execute, and the action input is the parameters. For example, we give examples in the prompt, which is very, very important because this is the output of the LLM. We follow this format and we can parse it afterwards. So we give it, for example, one example, we want to execute eddupe with docID. So this is the output that we expect. The action is eddupe. This is the first transform, and the input parameters will be that. And the next action, which is the next transform, will be docID. And you can see that we expect that the LLM will handle this thing that where the input of the transform is the output of the previous transform. So we expect that the LLM will generate this kind of parameters based on the example we give him. And the only thing we provide him is the first thing, the input folder of the first transform and the output folder of the last transform. But the intermediate transforms, the intermediate folders will be generated by the LLM based on the example that we provided. Next thing is to invoke the agent with this information. We give it, I apologize for that, my computer is a little bit slow. So we invoke him with the plan. We invoke him with all the parameters, and we get back, I can show you, I set the run, so to save time. So what we get from the agent is this big plan, which is in the format that we mentioned it in the prompt, where we have the list of transforms that we need to execute with all its parameters. We parse it. This is the output. And then we directly call each transform by calling its implementation, if it's in LangChain, as a LangChain tool or Llama Index tool, we directly call it, passing the parameters and execute the transform in the order. Okay, that's this experimental approach, and now I go back to the slides that what Muhammad started. So we had there are some challenges. Sorry, can see just a minute. There is an issue. Okay, you see my screen? No, I don't. I know lose. Do you see my screen?
Yes, but not in presentation mode. Slide.
Okay, I'll try one more time, and then if not, I'll ask you if that's okay to just. Do you see it now?
Yes, yes.
Okay, so the challenge that we had in using the agents is that we see that there is very sensitive to the prompt, and even small changes to the prompt can give totally different results, and it can be problematic. The context is limited. There is a limited amount of information we can provide. We depend on the AI agent. And there is like inconsistency output, partly because of this prompt sensitivity, and there is a need for human supervision, which can be helpful in this case. And of course, running an agent can be resource intensive, and in terms of cost. In general, this is like a view of others framework, agentic frameworks that can be used. We experimented with LangChain and Llama Index, but there is also CrewAI and B-Agent. And there is also this graph that's showing that LangGraph is the most popular. This is why we chose it. We first experimented with it, and the Llama Index. That's it, I think, for me. Any questions? I can.
Looks like we don't have any questions right now, but let me look at the chat here. Hold on a second. Let's see. Looks like, yeah, it looks like you've already answered the questions in the chat. I missed the earlier questions because my connection dropped and I had to rejoin, and it doesn't show me the chat from before I joined. So if there's any questions before 9:25, or I guess 25 minutes after the hour, that we did not get to, please add your question into the chat. I'm kind of curious, like, what are the next steps for this project? It's really impressive. Like, I would love to be able to use NLP to define a pipeline, and especially if we had something that we were doing over and over and over again, but we just needed to make some minor changes to it. I think it'd be super helpful.
Yeah, now it's experimental, so we just make it experiment with some tasks. Like all of the things related to LLM and the agent, all the hallucinations and things. So to be in a production, it's a bit harder to make all the, because it's a lot of change. Any small change can, as the challenge that Revital shows, any small change can change all the output, and also it's related to the LLM used. So we used with different LLM, we got a bit different output. So for production, it's a bit harder to get to there. but you can try it now when it's in the open source. The links, I think the links is in the meetup invitation, and you can try it and with different tasks and give it a try. And
So the primary usage is to do this in work in notebooks right now?
yeah, it's okay. Notebook I showed, you can just change the task. The task description and put your credentials for replicate or some Olama model, and you can run it without changing the other things.
That's great. Okay, so we have some other questions here. One from Adriel. How hard was it to link up LangChain with tools like PDF2 Parquet? What issues did you face in doing so?
Maybe
Yeah, I think it was quite straightforward. It's not very difficult to implement a new tool inside those frameworks. Also, Llama Index and at least the initial version. We experimented with it, but as Muhammad said, I'm not sure it's ready for production, but for the initial version, it was really straightforward, and the documentation is very informative. So it was just launching the tool, and we had some default parameters that we defined similar to DPK, and it was quite straightforward. It's also in the repo, so you can look at it.
Yeah, that goes into the next question from Ravit asked, is it all open source? And it looks like it all is according to the repo, but just can you confirm, is it all open source?
Yes. It's in the repo that I showed, the DataPrepKit repo.
Yeah, you know, it'd be kind of a cool project is to take this and try to implement. We have AlleyCat is a very simple RAG-based application that the AI Alliance has created really for demonstration purposes, and it's meant to be very simple so that it can be used with projects like this. And I think this would be, you know, and it does already use DPK for scraping websites to pull in the data into a vector database so that you can use it in a RAG architecture. Like to be able to maybe take an existing pipeline and then modify it, you know, from some new use case, I think would be like super useful and make it more approachable for a larger number of users.
Yeah. So
really, really cool. Okay, we do have some other questions here from Kieran. Does it mean that it will reduce the data engineering work by using DataPrepKit? I have my own thoughts on this, but I'm wondering what your thoughts are, Mohammed and Ravita.
It can help it's reducing the work because it's more automatic, and you can do it with no code. So it's also reduce work and also open it to a wider audience that can use it, not just data engineering.
Yeah, and Rivital, do you have anything else to add to that?
No, I think this is the main goal. Yeah, you don't have to know the details. So eventually, I think in Muhammad's case, it's more the case. You don't have to know the details of you know, how to call each transform, which is a big advantage. Yeah.
Yeah, my thoughts on this are that it will reduce the bar, meaning that it will take less effort to do the work. However, I suspect that what that means is, since there's a seemingly unlimited amount of work to do, it doesn't necessarily mean that there will be less overall work done. I think we'll end up probably doing more, but we'll just get more done in that amount of time. That's what I expect, at least in the next few years. That seems like the way this is going. There's so much work to be done. We'll just get more done.
Mm-hmm.
Okay, another question here is, how do you come out of the loop of verification of the answer is good enough? See, I'm not sure exactly what that question is. Does that make sense to you? How do you come out of the loop of verification of the answer to determine if it's good enough?
If I understand right, there is the loop that of planner and judge. So if the judge, it's an LLM judge. So if it says that it's good enough, it will continue, or there's a limit also. If we don't want to just iterate infinitely, so it's we put a limit, 5 iterations, 3 iterations, what we want, and if it's good enough, the judge said it's good enough, and it continue, or it's the limit, we got to the limit, so we continue with the plan that we have.
Got it. Very good.
I hope that answers.
That's a nice simple answer. Just set a number of loops and you're done, right?
Yeah.
I wonder if there's a way to do some sort of evaluation, but that can be a later date.
The evaluation is using LLM also, LLM judge. So
Yeah.
LLM as a judge.
Let's see here. Is there a link to, okay, Bob Parker asks, is there a link to find bugs and bug fixes of these tools? It looks like, Mohammed, you already shared a link to the code in the DataPrepKit repo.
Yeah, the Agentic directory has all the code, all the implementation of the graph, not just the notebook, also what's behind it, all the implementation of the nodes of the planner, judge, and so on.
Yeah, very good. And then Ravid asks, what about hallucinations? Have you had any experience with that?
Yeah, that's what Revital showed in the challenges, that it's the problem of the LLM. So you can, every change can, small change can make a big difference in the output, or sometimes using some other model got a strange output. It's using LLM, so always there will be hallucinations. But what we make to overcome this, for example, the first notebook, we output a Python file. So a Python file, when we got a good Python file, so we can run it several times, other users can run it. So now we don't relate to LLM or to some agent. We got a deterministic output, and we can use it without the problems of LLM and hallucinations and so on.
Okay, and as we near the end of the hour, or the top of the hour, Mehmet asks, can you share the slides?
Yes, where we can put it in.
I'd recommend, if you have the slides available, just to save them as a PDF and just, or I'm sorry, create a link to them right now. But another thing you can do is put them in your repo and provide a link to them there. Maybe save it as a PDF file and put it in your repo.
Okay.
And upload it there.
I can put, maybe I will ask, but maybe in the same folder.
Yeah, that'd be great.
Yes.
Okay, looks like that's it for now, but we're at the top of the hour anyway, so thank you both very much. This is
thank you for
really yeah, it's a really exciting project, and I definitely want to follow along with it and maybe try it out myself. If anybody else is interested in joining this project, you can email me directly, and I'll put you in contact, just so you have one email address to contact. Here, let me put it in here again. Or you can contact Mohammed and Revital also through the repo, or put your information.
I can put my email.
Yeah, go ahead. Yeah, and Mario says he needs more education. If you take a look at I'll post it in just a second so I get it, but you can go to our AI Alliance YouTube channel. We have a talk on how to get started with DataPrepKit, as well as Dockling. Those are both really interesting projects for if you're looking to clean up your data and scrape it out of PDFs or web pages and put it through a process of cleaning up for yourself. I'll post that link in just a moment. Okay, and I think that's it. All right, folks. Thank you very much for joining. We'll send out an email in a couple of days with the video, so if you want, you can share the video. And we hope to see you again next week, next Thursday, same time. All right.
Thank you very much. Bye.
Thank you, Mohammed. Thank you, Rafatal. Take care. Bye-bye.